Lawrence Cheung's pulse flywheel is an interesting device. For some time now, Lawrence has been presenting his theory of lead-out energy, which indicates that excess energy is drawn in from the environment when there is an impact. The method of producing this effect which he has followed is to create an unbalanced wheel and demonstrate that excess energy is produced. It should be stressed that energy is never created or destroyed, and so when he measures more energy in his device than the energy which he uses to power it, energy is not being created, but instead is being drawn in from the local environment. Lawrence has recently demonstrated a prototype to members of the public. His reason for doing this is that not everybody is honest and truthful when they present information. For example, take the current lies about COVID-19, which are based on the average person's lack of medical knowledge, namely, 1. Viruses are repair mechanisms which your body creates if you get ill or injured. 2. You can't catch a virus from anybody else, either directly or indirectly off a surface. 3. No virus has ever caused any form of illness. People don't understand that the main media, that is TV, newspapers, radio and so on, are all owned by the same group, and so they all tell the same false story if their owner tells them to. The same applies to free energy devices, in that it is denied that any system can have a greater power output than its own power input. This is based on the very silly notion of a closed system, which is supposed to be a place where gravity has no effect, light cannot pass through, cosmic particles never enter it, etc., etc. Pure silliness. Free energy is just a name for extra energy which flows into your apparatus from the local environment. For example, Teru Kawai built an electric motor with COP greater than 3. That is, the power output is more than 3 times the input power to make the device run. 2. Robert Adams built an electrically shielded magnet motor with a coefficient of performance of 8. That is, the output power is at least 8 times the input power. Floyd Sweet built a magnet system with COP equal to 1,500,000. Lawrence understands this, and so he wanted to demonstrate a simple and open device which anybody could check out using their own instruments. So, assisted by Mr. Tong and his team, this device was built using wood. This is a stator that you can see here, and inside it is a rotor which you can't see. It's powered by a battery, which means you can easily measure the amount of power being drawn from the battery, and then there are meters on, and you can use your own meters to demonstrate the actual power output from the device. This simple device was demonstrated to have 3.3 times as much output power as the input power needed to make it operate. This is an early prototype which was demonstrated in October 2009, and Lawrence and his helpers are working on to produce more advanced models which have kilowatts of excess electrical power. Mr. Cheung remarks, the Li-Cheung lead-out energy theory was first disclosed to the world on the 20th of December 2004 at Tai Po in Hong Kong. The lead-out energy theory basically says that one can lead out, or if you prefer bring in, energy from the surrounding environment into a lead-out energy machine. The lead-out energy theory does not violate the law of conservation of energy. The law of conservation of energy has been used as a roadblock for the so-called over-unity devices. The Patent Office and the scientific establishment routinely dismiss an invention as belonging to the impossible perpetual motion machine category if the inventor cannot identify the source of the extra energy. Lawrence says, "We got the help of Mr. Tong Po Chi to produce a 60 centimeter diameter lead-out energy machine in October 2009. The output energy of that device is greater than the input energy by a factor of 3 times. These results are confirmed by voltmeters and ammeters measuring the input and output energies." The Tong wheel has been shown at 2 open shows in Hong Kong. That's Inno Carnival 2009 and Inno Design Tech Expo in November and December 2009. Over 25,000 people have seen it. The Better Hong Kong radio show has video recorded it. The discussions being conducted in Chinese. At this time, the Tong wheel is at the radio studio available for experts to view and examine with their own instruments. The Tong wheel has a diameter of 600 millimeters, and this large size is considered to be important. It has 16 permanent magnets mounted on its rim and 15 air core coils mounted around it on the stator. There is one position sensor. The coils can be switched to act as a drive coil or a collection coil. That is, each coil can have one of 2 functions which you choose by operating a switch. This diagram shows the arrangement for this particular device. There are 2 pole changeover switches which allow you to switch the coil to be either a drive coil, shown in green, or an energy pickup coil, shown in yellow. There is a drive circuit, and that's the pulsing timing of the drive circuit is altered by the adjustable position of the sensor, which sends the rotor magnet passing by it. There are various ways of organizing this. If the position of the switches as shown for 10 of the 15 coils shown here, then they act as drive coils. The sensor is adjusted so that the drive circuit delivers a brief energizing pulse to those coils just after the magnets have passed their exact alignment position with the coils. This causes them to generate a magnetic field which repels the magnets, thrusting the rotor around. The pulse is very brief, so very little power is needed to accomplish this pulsing. As been mentioned before, any number of coils can be switched to provide this driving force. With this particular wheel, constructed by Mr. Tong, the best number has to be found to be 10 coils. It should be noted that this arrangement, where you pulse a rotor by giving an electric current to drive coils, is not an over unity arrangement. In other words, there is an energy loss in producing the rotation of the rotor by that sort of method. That's the sort of method that was used by John Bedini in his battery charging coil arrangements. The power pickup from this particular design is achieved by gathering the electricity generated in some of the coils as the magnets in the rotor pass by them. The arrangement for that is that the power collection circuitry is fed by the coils shown in yellow. Coils in green are still used in a different circuit to actually drive the rotor around. In this arrangement, 5 of the coils gather energy while 10 provide the drive. For the sake of simplicity, the diagram shows the 5 collection coils adjacent to each other, and while that would work, the wheel is better balanced if the drive coils are evenly spaced out around the rim. For that reason, this switching would actually be selected to give 5 sets of 2 drive coils followed by 1 pickup coil, as that gives a perfectly balanced thrust on the wheel. The 2 diagrams that I've shown you so far are shown separately in order to make it clear how the drive switching and the power pickup switching are arranged. The full design arrangement and the balance switching are shown in the following diagram, which indicates how the full design is implemented on this particular implementation of the wheel design. The sensor can be a coil feeding a semiconductor switching circuit, or it can be a magnetic semiconductor called a Hall effect device, which can also feed a semiconductor circuit. An alternative would be a reed switch, which is a simple mechanical switch encased in an inert gas inside a tiny glass envelope. So the complete circuitry, the way it should be organized, is shown here. You've got the drive circuit, which is synchronized by the input of an adjustable sensor, and the drive circuit then pushes the coils shown in green, and they drive the rotor around. The power collection circuitry uses the other coils, the ones shown in yellow, and the feed from those coils caused by the magnet passing by is fed through to the power collecting circuitry on its drive board. Mr. Chung remarks that the large wheel size is due to the fact that the pulse force takes time to impart the impulse to the wheel, and lead out energy from the environment flowing into the system is caused by that. It's planned to produce a version which has a 300 watt output and another with a 5 kilowatt output. Educational kits are also planned. If you decide to replicate this particular design, then to raise the output power level you might consider putting another set of coils around the wheel and either using them as 15 additional energy pickup coils, or alternatively pulsing the wheel twice as often. Adding one or more additional rotor discs to the same rotating shaft is also an option, and that has the advantage of increasing the rotor weight and improving the effect of the impulses on the rotor. The diameter of the wire used to wind the coils is a design choice which has a wide scope. The thicker the wire, the greater the current and the larger the impulse given to the wheel. The coils are normally connected in parallel as shown in the diagrams. Because of the way magnetic field strength drops off with the square of the distance, it is generally considered good design to make the coils 1.5 times as wide as they are deep, as indicated in the diagram above. But this is not a critical factor. Although motors of this kind can be built in many different ways, the construction used by Mr. Tong has some distinct advantages. So there is a little more detail here now on how I understand the construction to be carried out. The rotor has the north pole of the magnets embedded in it facing outwards. The side of the stator which supports it has got a number of cross timbers attached to it, which run across to an identical far side stator. There are 2 side pieces, and they're attached together by 16 cross timbers, each of which are held in place by 2 screws at each end, as you can see them there in this close-up photograph. This produces a rigid structure, while the construction method is as simple as possible, using readily available materials which are worked on with the most basic of hand tools. The construction also allows the motor to be taken apart completely without any difficulty, transported as a flat package, and then assembled at a new location. It also facilitates people who want to see the motor taken apart after a demonstration, in order to assure themselves that there is no hidden power source. Each of the cross timbers provides a secure mounting platform for an electromagnet and its associated switch. In the implementation by Mr. Tong, there are permanent magnets mounted in its rim. The magnetic poles of these magnets are all orientated in the same direction. That is to say, the magnetic poles of the rotor face outwards. They're all either south or north facing poles. It's not critical whether the outward facing poles are north or south, but having said that, most people prefer to have north poles facing outwards, and it is said that north pole to north pole action between two similar permanent magnets is slightly stronger with the north poles than it is with the south poles. I have to admit that's not something I've tested myself, but it's a fairly widespread opinion. If we're just starting to experiment and test a motor of this type, it seems sensible to stick with what Mr. Tong has found successful. However, this build by Mr. Tong is not his final motor, but just one in a series of continuously improved motors. Following diagram shows an arrangement which is 3 rotors attached to a single shaft, and while you may choose to construct this way with just one rotor, if the cross timbers are long enough, then 1 or 2 extra rotors can be added in very easily at a later date. And this is the arrangement, the same side view as before, the same cross timbers as before, and on the cross timbers you can mount the coil which corresponds to the rotor and its connecting switch beside it. So you can have either 1 or 2 or 3 rotors if you want, all on the single axle. The electromagnet coils used by Mr. Tong are air core, as that type have the least effect on passing magnets. However, electromagnets with cores tend to be much more powerful for any given current flowing through them. In theory, the core should be made of lengths of insulated iron wire, as that would reduce power loss through the eddy currents flowing in the core. But Robert Adams actually recommends solid metal cores, and as he was the most experienced person in the field, paying attention to what he said seems sensible. The core material needs to be a metal which magnetizes easily and powerfully, but which does not retain any of its magnetism when the current stops flowing. Not many metals have those characteristics, and soft iron is usually recommended. Nowadays, zinc-plated soft iron bolts are the cheapest type in your local hardware shop, but bring a magnet with you to test the bolts before buying them. With the core in the electromagnets, the rotor gets additional rotating power. Initially, the magnets on the rotor are attached to the electromagnet cores, giving the rotor a turning force which does not require any current to be supplied. When the rotor magnets are at their closest point to the electromagnet cores, the windings are powered up briefly, and that gives the rotor magnets a strong push away, causing the rotor to spin. There are many different designs of simple drive circuits, and it's probably worth trying out different types to see which works best with your particular build of this motor generator. In the same way, there are many kinds of collection circuits for taking off some of the excess power generated. The most simple of these is just a diode bridge, perhaps feeding a battery and charging it up for use at a later time, and ideally with a capacitor across it to store the pulses completely. You can get sophisticated with the collection circuits and just take power off for a very short period of time at the correct moment. The cutting off of the current draw causes a back EMF magnetic pulse in the collection electromagnet, which causes it to give the rotor an extra drive push, so it acts both as current collector and rotor drive in one combined package. Here are two of the most simple circuits possible, one for the drive and one for the power collection. The drive circuit transistor is switched on by voltage generated in the grey coil here, caused by a magnet passing by it. The transistor then feeds a large current pulse to the black coil, driving the rotor on its way. The neon and the 1N4001 diode are there to protect the transistor. The pickup coil has just got a diode bridge across it on this particular diagram. Having a capacitor between the minus and plus output leads from it would be probably a good idea. This is a possible physical layout for this particular circuit. The coil with the two windings on it, which is a bifilar coil, is part of the circuit here, and the components are screwed into an ordinary electrical connector strip. It works very well indeed, that particular arrangement. The 1K variable resistor is adjusted to give the best performance, and the on-off switch is optional. More advanced circuits can also be tried and the performance compared. Generally speaking, I would expect a 3-rotor version of Lawrence's generator to give a better performance than a single rotor implementation, but experimentation is needed to check if that is actually so.